Again, this is from chapter 10.3, and it is a two-sample F-test of variances. This test is used when we do not know whether the variances are equal or not for two populations, two samples. And so what we want to do is test to see whether they're equal, and that will help us then, especially if we're going to test the means next, to figure out whether to use a pooled variance t-test, which we would do if we discover the variances look to be equal for the populations, or we'd use a separate variance t-test if they appear to be unequal, if we have to reject the null. We will do this pooled variance, separate variance approach using PhStat. So the main difference in the separate variance test is that the degrees of freedom are changed, and therefore the critical values are changed. But you don't need to worry about that. The computer will do that for us if we specify the correct test. You may remember this problem. This is the same problem that I did from section 1 of chapter 10. It's problem 10.8 on page 331, except now we're going to test the variances, not the means. So you'll notice the data is the same as it was before, but now it says in part A, using alpha equals 0.05, is there evidence of a difference in the variability of the two groups? So variability is what we're looking for, variation rather than means. So this is the information we're given. X bar 1 equals 36, S1 equals 21.4, N1 equals 51. And so here's our sample data. Then we did an F-test of variances using Excel with PhStat. And this is what we ended up with. So it's an F-test of differences in two variances. 0.05 was the alpha level. These are the values that we had for the samples, two samples. And this is the F-test statistic, which is step 5. And this is my upper tail critical value as well as my p-value. It says, do not reject the null. So that gives us a pretty good idea that we should be able to use the pooled variance t-test to test the means. But let's go through the steps, see how we would write this up, and how we come to that conclusion. Step 1, null and alternative. So the standard deviation, the null is, the standard deviation for the celebrity endorsement advertisement is equal to the variation for the alternative, or you could say sigma squared 1 celebrity is equal to sigma squared 2 the alternative. Okay, so the variances are equal, the variances are not equal. That's what my null and alternative says. Step 2, these are my sample sizes. N1 equals 51, N2 equals 41, alpha equals 0.05. Step 3, I want to use the F-test because I'm testing two variances and I'm assuming the populations are normally distributed. I'm trying to find out whether the variances are equal or not. Of course, I'm also assuming independent random samples, and this will then help me to decide which test of means perhaps to do if I need to do that. Step 4, critical value of F, that is the upper tail critical value, 1.8324. And I compare that. That's step 4. All I do is write down the value. You notice it's an upper tail test, which means a high value is going to cause me to reject. Here's my F-test result. Now, this is a two-tail test, so what I really could do here, well, given my test statistic, I'm only interested in this value, 1.6719, and it's not beyond this upper limit, which I'll see in the next step. So the calculated value is 1.6719, critical value 1.8324. So therefore, in step 6, fail to reject because 1.6719 is less than 1.8324. I have 0% confidence because I've failed to reject, but there's not enough evidence to say with 95% confidence that we can reject the null. Therefore, we will assume the variances may be equal. This would lead us to use the pooled variance t-test if we were going to test the means. Again, if we rejected the null here, that would tell us to use the separate variance t-test. And all we do is specify a different test under PhStat or even under data analysis if we choose to use that. So what we're going to do for our take-home part of the exam is going to be very similar to this. We're going to start out with a set of data. We're going to test the variances, and the question will be very similar to what it said in the beginning here. Is there evidence of a difference in the variability for the two groups? And then, depending on the results, part B would say, well, let's look at the p-value for this particular problem too. Notice the p-value says right here 0.0954. So that means that if I were willing to use 90% confidence instead of 99, I could in fact reject the null. And that would say there may be differences in the standard deviations for the population. But since we wanted 95% confidence, we're going to continue to say it looks like they may be normally distributed. Looks like that we cannot say that there is a difference in the variances. Okay, so again, how will this take-home part be worded? You'll have a question similar to this: is there a difference in the variances, for which you use the F-test? And then we want to know, is there a difference in the means? In which case we would use a t-test, either the pooled variance t-test if we found the variances were equal, or the separate variance t-test if we found they were not equal. And you could come up with a different result when you test the variances and the means, so that's why you test them separately. And what you do is you write up the 6 steps for each of those 2 problems. And you provide me with the computer printouts to tell me where did these numbers come from, and that's pretty much it. So the problem will be similar to this, different data, but use this example to help you to know how to do it.